Hey guys, this is the second half of section 6.4. I would suggest that you write things down, hit pause when you need to think about it, or hit rewind so that you can hear something again. Make sure that you are not just passively watching it, and have paper and pencil ready just like you would if we were in class. Alright, so we are going to graph logarithms first. We have already graphed the exponential function, and I just want to remind you that the exponential function and the log function are inverses of each other. And so it's really important to our graphing because we know things about inverses in their graphs. We know that they flip over the line y equals x, and we know that their x and y coordinates switch places, and that's really important to us. Notice that a is the base of the exponential function. It's also the base of the logarithmic function, and that's the whole basis for how we're going to graph this. Okay, so we're going to do this the same way we did for the exponential functions. We're going to move the origin and plot 3 points and put an asymptote on it. Okay, so first I just want to look at the graph of a to the x. A to the x looked like this. I want to remind you of the 3 important points that we had there. This first point was at 0, 1, and then we went over to 1a, where a is the base, and we went over here to negative 1, 1 over a, again, where a is the base. So if we're going to graph the log function, then it's going to reverse all of that. We're going to flip this over this line. So instead of 0, 1, we're going to go to 1, 0. Okay, and then instead of 1a, we're going to go out here to a1. Just choosing an arbitrary a here. And then I'm going to go to 1 over a, negative 1. So here we are. We'll call that 1 over a, negative 1. Alright, also remember that it had a horizontal asymptote at 0, and so our graph, because it's the inverse, is going to flip that, and the asymptote will become the vertical asymptote, and it will also be at 0. Okay, so here's our asymptote. So this guy, I say that he looks like the Loch Ness Monster, so when you hear me talking about Nessie or Lockie, that's what I'm talking about. He just comes up here and there's his head. Okay? So this is our log base a of x. The vertical asymptote is at 0. The domain is 0 to infinity, so we start here. The range is negative infinity to infinity. It goes through the 3 points that are flipped. So now we go through 1, 0, go through a, 1, and we go through 1 over a, negative 1. Be sure you understand where those 3 points came from. We don't want to memorize 2 sets of points, so I'm going to do something kind of weird. We're going to use our flipping of x and y to help us out here. Okay, so stay tuned. It's going to get kind of weird. But know that the shape of it looks like this. Remember that it's flipping over y equals x. Alright, so we're going to graph log base 2 of x plus 2. The base is 2. That's our a. So this is the inverse of 2 to the x. This plus 2 in here means that we're going to the left 2. And so I'm going to take my origin, move it to the left 2, and there's my new origin. Remember our vertical asymptote was on the y-axis? Well, now it's on negative 2. So the vertical asymptote is negative 2. Okay, put him in there. Alright, when we go to make our 3 points, I'm going to have you use 2 to the x because we already know those 3 points and we don't have to learn something new about it. So I put in 0, 2 to the 0 is 1. I put in 1, 2 to the 1 is 2. I put in negative 1, 2 to the negative 1 is 1/2. We already know that from before. But wait, this is the inverse. So I'm going to flip those, and we're going to do log base 2. So instead of 0, 1, it goes through 1, 0. Instead of 1, 2, it goes through 2, 1. Instead of negative 1, 1/2, it goes through 1/2, negative 1. Be sure you know where those are coming from. We just flipped the x and y coordinates because we are doing the inverse. Log. From our new origin, I'm going to go 1, 0 here. I'm going to go 2, 1, 1, 2, 1. I'm going to go 1/2, negative 1. So from here, 1/2, negative 1. Going to approach the asymptote, and there's old Lockie. Nice. Hit pause and rewatch that. Moving on, this one's going to give us a little bit of trouble. He's got 3 transformations. The first one is to the right 2. The 3 is a vertical stretch of 3. And the negative flips over the x-axis. Okay, so I'm going to take my origin and move it to the right 2. There's my new origin. Okay. In order to take care of these things, though, we're going to have to do some other stuff. So let's go and make our table. Remember, base of 2. So this is 2 to the x as our parent function. So we do our 3 points again. Be sure you know where those are coming from. Okay. I'm going to flip those around so that now we're talking about log base 2. So here's my flip. Flipping. Flip them again. There you go. Okay, here's our 3 points, but I want to do a negative 3 times that. That negative 3 is a vertical change. Vertical changes affect y. So, negative 3 times the log means I'm going to take negative 3 times the y coordinate because I'm stretching the y's. Well, it's 0. Take negative 3 times the y coordinate, negative 3. And take negative 3 times the y coordinate is 3. Hit pause, make sure you understand where those came from. Now I'm going to come over here and plot my 3 points from the new origin. Here we go. First of all, vertical asymptote is now at 2. Put him in there. I'm going to go 1, 0, go to 2, negative 3, go to 1/2, positive 3. Keep in mind what this looked like. Remember old Lockie? Now he has flipped over this way, vertically, okay? So this tail end is up here, and his head is down here. There he is, okay? Pause and make sure you understand where all that came from. Let's do one with e. 3 plus ln x means that it's going up 3. So I'm going to go move my origin up 3. Does my vertical asymptote change? No, it's still 0. So I'm going to put that in there. Ooh. There we go. Okay, ln x means that the base down here is e. There's an e down there. So when I do my table, I'm going to do e to the x. Now you may not remember what those points are, so get your calculator out and complete your table. 0, 1, and negative 1. Remember, use the e to the x button. E to the 0 is 1, e to the 1 is 2.72, e to the negative 1 is 0.36. Check that out on your calculator. We're going to do these from the new origin. So here I am, 0, 1. Oh, sorry about that. Back up the truck. We got to flip them. I forgot. We're doing ln. So let's flip these guys. 1, 0, 2.721, and 0.36, negative 1. Alright, here we go. New origin, flipped points, and there they are. And there. Okay, plot your points, There's Lockheed. Now we're happy. Okay. The other thing we need to take care of is solving some equations. Our new trick of the day is to change the form. If it's in exponential form, we change it to log. If it's in log form, change it to exponential. That way it will be easier to work with, something we can solve. Don't forget about our previous rule of the day, where the bases are equal, the exponents are equal. Alright, here's this. I have log base 4 of x equals 2. So I'm going to take 4 to the second equals x. That's the exponential form. 4 squared is 16, and good to go. I want to remind you of a domain issue. We have 3 domain issues to worry about now. And this one says we have to take log of a positive number, not even 0. So if I put 16 in here for x, will I still be okay? The answer to that is yes. So it checks out. So be sure to write down that you need to check your solutions. Okay. Over here, we're going to change him to exponential form because he's in log form and I can't do anything with this. So I go x to the second equals 64. Take the square root, and I have x equals plus or minus 8. Don't forget, it's plus or minus when you take a square root. In this case, will both of those two work? Can I have a log base 8 and a log base negative 8? The answer is nope. So only 8 is going to work. Okay, you can put it in your calculator to see if it gives you an error if you're unsure. Okay, let's take a look at this one. I need to write it in exponential form. Pause and write it in exponential form and solve it and then come back. This is 3 squared. It's 4x minus 7. So 9. I'm going to add 7. And I'm going to divide by 4. So the question is, if I put 4 in here for x, will I still be taking log of a positive number? The answer is yes. Let's come over here and try this guy. Again, pause, do the problem, come back and see if you did it okay. We're going to change to exponential form. 3 squared equals x squared plus 1. That's a 9. Subtract your 1 and take the square root. Now here's where things get dicey. This is plus or minus because I took a square root. Square root of 8, you may never change it into a decimal if there's no word problem around it. So this is exact form, but I need to change this to a reduced radical. So make your little factor ladder. If you remember, when you have a pair, one comes out. And when you have a single, he stays in. Okay? And now we would go and check these out and make sure they both work. So I'm going back in here. If I take positive 2 square root of 2 and I square it, I get a positive, plus 1 is positive. Good. If I take a negative 2 square root of 2 and I square it, I get a positive, plus 1 is a positive. So both answers work this time. Let's change it up with e. These are in exponential form. I can't work with it this way, so I'm going to work with it in log form. Change them to log form. So the log is log base e, which is ln, of 5 equals 2x. You may not touch your calculator. We are going to solve in exact form. So we're going to leave this ln 5 over 2 equals x. Leave them alone. That's exactly how we want it. Let's do that again over here. We're going to change it to log form. Base is e, so it's ln of 13 equals negative 2x plus 1. And we're going to solve for x. Do not touch your calculator. We're going to subtract 1. I'm going to put 13 in parentheses so I know that the minus 1 has nothing to do with this 13. This is part of the ln. I have minus a negative 2x. Divide by negative 2. And I want you to leave it just like this. Exact form, no calculator. Okay. Now, I've got two beautiful problems here. Let's start over here. These happen to go with word problems that are in your book. So this time we are going to touch your calculator. We are going to go ahead and get a solution. So I'm going to need to get the E part by itself. So I need to get rid of that 760. So we divide both sides by 760. And 320 divided by 760 is 0.42. Okay. Now we're ready to turn this into log form. It's a base of E, so it's ln of 0.42 is negative 0.145h. We're going to solve for h, so divide. This, you may put your calculator to use now. So we're going to do ln of 0.42 divided by negative 0.145. And if I didn't make any typos, well, looks good. All right, I got 5.98. Now, I'm not in love with this 0.42 business. I would much prefer to have it more exact. So if I were doing it actually, I would probably leave this as 320 over 760 until I got to the end, and then put the whole thing in my calculator. It may or may not make a lot of difference in this one, but later on it will make a lot of difference. So we will keep that in mind for another day. We're going to do that again here, solving for t. Again, this came from a word problem, so we are going to use our calculator and get a decimal. I need to get the e portion by itself, so we're going to get rid of the 1. So I have negative 0.5, negative e to the negative 0.15t. I want to divide both sides by a negative, and so what happens is they just both become positive. And then change its form. And divide. Now at this point we're ready to grab a calculator and see what we got. And I have 4.62. Okay. Alright. Well, that should do it. You are going to need to finish 6.4a. Now you have 6.4b to add to it. Yep, there's a lot of problems, but some of them are really quick on these. And then you also have your coloring sheet for extra credit. The colored pencils and markers are on the bookcase behind the podium. You're welcome to them. I would not use markers, sorry. Use colored pencils or crayons. If you don't have one, I've left them with Mrs. Semino, and so she can give you a copy of it if you were gone or you don't have it or you really messed up. I have extra copies. Alright, good luck. Have a good time. Make good decisions this weekend. Thank you.